I'm happy to have everyone in class today. I would start as I usually start by reviewing what we've discussed in previous class, then moving on to what we'll be discussing in today's class. So in previous class, we were able to talk about iterators. We also spoke about enums. We spoke of how important enum can be in the Rust programming. We also spoke about how useful the match pattern is. We spoke about how important it is that whenever you are basically using an enum and you need a comparison, how important it is to use the match pattern for that. We then went on to talk about the iflet. So we spoke about how you can use that when you want to have just one condition to be true, and then the code in that block can then run for that. Then we went on to dissect iterators more, and we were able to, in fact, talk about certain iter methods. So we spoke about how an iter is basically a trait, and how evoke, when it after implementing the trait, how it basically have the ability to call these methods ranging from mapping, filter, or position, find, all of these item methods, how all of these item methods can be used and how they can basically be changed together. So all of this is what we discussed yesterday in our previous class, I mean, and thinking about it, it's more like much exposure towards the work we had in class, the implementation of the library that we actually did. It's more exposing the different methods that were used that might feel foreign to us when it was being used. So that was a class that exposed us to it. So we did not write so much of code for the class where we talked about enums and the iterators. We did not write so much code, and this is because we just wanted to have the fundamental knowledge of it. And for that, I have kept that in mind, as that is going to be part of what we'll be having on Monday. We would have a class quiz where everything that has been discussed concerning enums and match statement, including iterators, there would be a class quiz where the quiz will be done on the call. And so everyone would definitely have to, practice it on the call. And those who have problems or challenges with the quizzes can basically, sort help right here on the call. And that's going to be on Monday. So this is just like a preparation to what the Monday's class is going to look like. So coming into today's discourse, for today's lecture, we'll be talking about modules, workspaces, and testing in Rust. This is going to be the major discussion we'll be having today. And one might then ask, why exactly are we talking about modules? Why are we talking about workspace? Obviously, when I talk about testing, what comes to your mind? All of this is going to be the highlight of the class we'll be having today. So what exactly is a module? Modules are a way to organize and encapsulate code into separate logical units. What exactly does this mean? This means that all we have been doing on this call, when it comes to practical, that is writing the code, we have not written so much of a bulky code that have so many parts. But then as time goes on, when you start writing a very big infrastructural code, then you start understanding how important it is for you to encapsulate some code and organize it in different folders and different modules. So what module does is it allows you to organize your code very well. So the ability for you to organize your code very well makes it possible to, in fact, reuse some of your code in different areas. So all the codes you have in just the main.rs that we have been working on, you have the opportunity to create so many files, and these files basically serve as different modules where you can have all the different infrastructures or code base that you would want to use in separate files. And this basically allows you to have your code organized. Now, I would use, just for a better understanding of where I'm trying to go, I'm going to use blockchain, since what we are basically talking about is still blockchain. I'm going to use blockchain as an example. And there's, what I'm going to use will be based on the EVM blockchain. And talking about the EVM blockchain, definitely you will be talking about, Solidity. Now, there is an EIP in Solidity that is called EIP 2535. That's the Diamond Standard by Nick Mudge. Now, this kind of Diamond Standard is a kind of code base whereby you have so many files. All of these files, some are the facet, some is the diamond, and all of these things. But then how do you arrange these different files? Well, in that case, each of these files needs to be imported inside another file where it is used and all of that kind of use case. That's an example of what a code organization is. So in the case I have just made mention of, its Solidity. Now, coming to Rust's side, you might want to have an implementation, probably for backend side. You might want to implement your server. You have a different module where you have your errors organized. You have a different module where you have the code base for the client to interact with the server. You have a different module where you have other implementations. So doing this allows you to really organize your code. And just like you can see on the screen, real world example, imagine a project with utility, data processing, and network communication. You understand? All of this code would not just be jam-packed in a single file like the main.rs we have been using for our code. All of this have to be organized, and this organization needs to be learned on how it is being organized and how these codes are being imported. So how do you declare and use modules? The example you can see on the screen gives an exact example of what a module looks like. Declaring modules, you basically declare mod and then the name of the module. And then whenever you want to use the module, you can basically use the module by, for example, the example I have on the screen says utilities, and to use these utilities, you have a function greet inside the utility. Then what you do is then you call this and you have 2 columns, as if the same way you would have called an enum that you are creating, or the same way you would have initialized a struct when you are implementing it, or more like calling the first method of that struct. That same idea of what it looks like. That's exactly what using a function that's inside like a module. That's exactly how it looks like. And as you can see from the screen, the module utilities has a function greet, and then you are trying to use this utility as a module inside the main.rs. I mean, everything is literally inside the main.rs, but you are trying to use it inside the main function. And so this is how you call it: utilities, column, greet, and then the parentheses. So that's how you do it. Now, in the case whereby you split the module into its own file. Now, just like I made mention of, this particular module is declared inside of the main.rs. But then what if you have the modules splitted? Well, here is how you do it. You call mod utilities, and then you import it. So you declare it and you link it to the utilities.rs. Well, looking at the screen like this, it would not be too beautiful without, looking at what we are talking about and then implementing it. And so for this very reason, I will stop sharing my screen here and reshare my full screen, and then we can then see what I'm talking about. So I don't know. Saroja, I think your hands are up. Do you have anything you would like to say or any question? Because I noticed your hands are up. Can everyone hear me? Saroja, can you hear me?
Yeah, we can hear you.
Okay. Okay. I guess its hands are up, but I am not sure it has something to say. So I created this file so we don't waste our time.
Can you make it bigger? Sorry.
Yeah. So I created this file and named it modules. And it's going to be what we would be using to experiment what we are going to do today. So I'm going to do what we have normally. Normally we have, to create a function, we basically create, I'll call this shout function. And all it does is it prints, I am shouting. That is all this function does. Normally, okay, I'll remove this. Normally, if I call this shout function and I open the terminal, if I console.log it, did I just say console.log? Instead, if I can run it, obviously, it's going to build what I want and it's going to say I am shouting. So basically, right now, I have just written a function inside this main.rs. But now in this case, I want to put this function shout inside a module. How then do I do this? I do that by creating this module mod, and I'll name it shout. Then parentheses, and then I would move all of this inside the module. If I save this, notice that there's going to be an error, a compiler error. Why do we have a compiler error? This is because this function shout is no longer in this same file directly. Rather, it is inside a different module. I just said a sound. Is that someone asking a question or wanting to say something? Okay, if that's not, I'll proceed. So this means this file can no longer access it. So to now access this, all I have to do is what? Add shout, and I save. Now, notice that we have another compiler error. Why do we have a compiler error? I mean, we've added the shout there and we believe it should now have access to this function. But that is not what's going to happen. It's going to give a compiler error because this shout inside of this module is a private function. What does that mean? That means that this shout is only exposed to the particular scope it finds itself. And so to outside of this scope of this module, it is a private function. Private function means no other file or module can basically have access to this function. But then, what do we do to now allow other files and modules to have access to this function? We make it a public function. To do that, you add pub. So adding pub to the front basically makes this particular function inside the module a public function. A public function means this file, main.rs, can now have access to function shout from anywhere. So if I run my code now, I can basically have I am shouting called here. Basically. So does that make sense? Or does anybody have any question concerning what I've just explained? If there are no questions, I would proceed. So Rust expects the file structure to match the module path. So that means that the file structure must match the module path. So you cannot say you want to import a different file without actually having to do what? To import it directly inside the file you are trying to import it. And moreover, it must obviously be a public function if you want to have access to that function. Notice that I have not shown how to work with a file from a module from a different file, which I'm definitely going to show before the end of this class. I just want to talk about the public and the private module, and here it is. So to expose functions, struct, or other modules, it's important that you use pub. And this pub basically allows you to gain access to this module. And that is exactly what I've just explained from the code that I showed. And in this case, imagine you want to have like a module, and that module, all it does is it have like a math library. It serves as a module for a math library. So in that case, to have access to all of these functions, you definitely need to do what? You definitely need to add the pub. Now, coming to this side, there are multiple levels you can create your module. What does that mean? That means that a module can be inside of another module. And what this means is that if the inner module is not public, it is not made public by adding the pub function, no function outside of that scope can have access to it. And that's exactly what we can see here. We have a module that says outer, and then we have a module that says inner. Now, this inner module has a public function, and it called it public function basically. And the other one has another inner function, and he called it a private function. Now, if you look at the main file, it's impossible for you to access this function, private function. How true is that? Let's experiment it. So going back to our code, we've used shout. Let's basically use something without using shouts. Let's use public mod. Let's name it public mod. And then we have another mod inside it. Let's name this one outer mod, just to, have the other name similar. So I'll name this one inner mod. So we have inner mod and outer mod. I'm going to name this the first function. I'm going to name it first. And then I'm going to just print something here. And I'm going to call it I am the first. Now I'm going to have another function inside here. And I'll call it second. And in this second, I'm going to print it and say, I am the second. Now, okay, I'm going to remove this since we've commented it out. Now, notice something. We have this module inside of this module. That means that you can have more than one module inside the module. Now, inside this module, we have two functions, and both of them, we never added the pub in front of it, meaning we did not make them public. But I'll try to call them. Inside the main, in fact, I'll take this out. Inside the main, I will call outer mode. Then here I would say inner mode. Then I'll say first. Do you believe we will have a compiler error? Yes. But why is the compiler error not on the first? Because I mean, this one is not public. This one is not made public. It's literally private. So why don't we have the compiler error on this first? Rather, why are we having it inside on this inner module? The answer to that is because the inner module itself is a private module. So that means if you have a module inside another module, that module becomes a private module. What that means is that if you have a module inside a module, you have to add the keyword pub in front of it. And the moment you add it, it becomes a public module. Adding the keyword pub in front of it now makes this inner mode accessible. What that means is that you can now see what is inside the inner mode. But then we have the compiler error on this first. Why do we have the compiler error on this first? Simply because it is a private function. So to make it a public function, we will definitely also have to add the pub. So that means that inside this module of module, we made this a public function and made this a private function. So you can have private and public function in the same module. It doesn't necessarily have to, you don't necessarily have to make everything a public function. This is usually the use case whereby you are using some particular functions as private functions because they are just helper functions. You do not want to expose this function to other files or other modules because you are just basically using these functions inside another function. A situation of this could be arithmetic functions, a function where you use to do certain calculations and the function is only used inside that particular scope and you are not needing that function outside the scope. So there might possibly be no need for you to have the function as public. Up to this point, does anyone have any question based on what I've just explained, or do I proceed? Can I see a thumbs up if everyone is still with me, just to ensure that we are together? Okay, great. Okay, great. Great. So moving on, importing modules with use. The use keyword is used to simplify accessing module functions or types. This is because there are different modules you can have outside of the file. And for you to use these particular modules, it is important that you import these modules. And to import these modules and to use these modules, you use the keyword use for the module you are importing. So you can import multiple items from a module. Like for example, in this case, we have a math module that imports add and subtract. And for deeper parts, you can have a module inside a module inside a module and have a function inside that module. For this, you can even extend it to have the column until you get to the particular function you need in the module. So let's practicalize this and see how we can have a module inside another module. So for this, I'll call this mode.rs. And then I'll have something else. I'll call it math.rs. And for this math.rs, it is automatically a module itself. So inside this module, I would have function add, and I would call it AI32 and B I32, and then it should return an I32 and basically A plus B. I'll add this subtract function, basically the same, I32 B I32, and then it should return an I32, and that's A minus B. So yeah, notice something, that this is not even looking bright. If I divide my screen, notice that this is looking brighter than this, although that is coming from my own extension. Notice that this is not looking as bright as this. Why? This is because all of these cannot be accessed here. So let me try to say math and then add, and I add 1 and 2. Would I have a compiler error? Yes, definitely. That's because where is math coming from? Undeclared creator module math. That's because math cannot be found anywhere. So to do that, you come to your mode RS here, and then you say pub mod math. And so you use it. So use math. Do we have a problem? Okay, let's make this public. Public. Okay. And so why is it not finding it? It's not included in any crate. Good. So for that, we need to do what? Add it in the crate, and then mod is equal to mod. Yeah. So can we find it now? No, sorry. Why can we not find mod inside here? Give me this. Sorry. Mod. But why can we not find it here? Is this a compiler error? So let's try to make this public, and you say use math. Then, okay, let's make this public by saying for math. Let's name this math. We didn't add the mod here, mod pub math. And then let's bring it all here and add this here. File is not included anywhere. Okay. Fix. Insert it. Okay. Okay. Okay, sorry. Okay. So yeah. Here's the main.rs. Math, and then we can basically use maths, and then inside here we can have add and sub. Okay, so what exactly did we do? We have a particular module that we named the math module. Now, this math module have the function add and function subtract. Now, for us to have access to this math module, we declared it here, and then we used it here. So for that reason, and we used it here. And now doing it this way gives us the opportunity to now what? Have access to both add and subtract. So in this case, we have add and subtract inside of this module. And all of this is accessible because every single one of it is a public function. Now imagine I remove this and I try to use the add here. It is impossible to use the add here. This is because the add is not accessible. So that's just basically it. So I'll return it back here. So you can use the add here. So if we say, if we want, we could basically even use subtract 1 and 2, 1 and 1. I mean, let's do that. You can put them here and say, let's results equals this, and you print it out. Print out. So we have add a sound here. Okay, do you have a question or something?
Yes, I actually have a question.
Okay.
So I want to ask that, is this similar to some kind of using interface to relate with another, let's say another code base or something like that?
The answer to that is no. When you talk about using an interface to relate, I know you might probably want to have the idea of something like Solidity, having an interface and you have list of your functions inside it. Basically, it's in fact does not necessarily have to be your function. It could be your function signature inside that interface, and then you want to use this function signature to interact with a different smart contract. I understand all of that you are thinking it is from that perspective. But the answer to that is no, it is not. Rather, you can see this as creating a library. So this module, you can basically use it to create a library. So you can have a library, and then these different libraries, you can then use them inside your own code base. And that's exactly how it works. So I don't know if you get it. So having this mode, you can, although we have not gotten to the point where we teach how a crate is being published to crate.io. We've not gotten to that point where we teach that, but as time goes on, we would get to that point where we teach how a crate is being published to crate.io, basically. So that's exactly it. So does anyone have any question apart from that? Okay, great. So that's basically, going back to our code, that's basically how you access it. I really don't like seeing my compiler. It says check failed to load source for dependency in merge caused by updates merge. Oh, if I come here, I should remove this, and then that is solved. Okay, so now that brings us back to this. Can't find add in mod. Which of the mod can you not find add? Oh, it's true, you won't find add. Rather, let's name this add up. And then we put the add here, the 2. Let's use this as 1. And then, yeah. So definitely. So why exactly was it saying you won't find add? This is because I have already imported the add, then I'm still trying to access it from this point. So why should I be accessing it from this point when I have already, added it? and destructured it here. So there are some cases whereby you might have so many functions inside this module. When you have so many functions inside this module, you might not want to start importing one by adding all of the different functions here. In that case, all you have to do, remove this, and then you add star. So once you add this star automatically allows you to import all the functions you have inside this module. So now, due to the fact that instead of adding and destructuring the particular functions I want, rather I can now, this particular module, the main.rs, now have access to all the functions I have here. Only and only if they are made public. Now, a situation might come up whereby you might also want to create a struct. I know we have had previous classes on structs. Let's say we create a struct, let's name it data. Inside the struct, we have the name, which is string. We have the address. Let's call it string. Also, we have the age. Let's make it an I32. We have, I want to add one more thing to it. We have married. And let's name that Boolean, a bool. So for these structs, can we have access to this particular struct in this main.rs? The answer to that is no. But then, how can we have access to this struct in main.rs? All we have to do now is to add pub. Adding pub simply means this particular main.rs can now have access to this data. So from there, let's remove this. From there, you can have let data structure. Oh, I made a mistake. Data structure equals data. Notice that there's going to be an error coming up now. I'm going to have it as name, string from IO. I'm going to have address, and the address is going to also be a string, and I'll have it from, let's say this is a string of the address, and then age. I'm going to have the age as 10, and then for married, I'm going to have it as true. So now, we could have access to this data because, as you can see, it recognizes it. It recognizes it. It's recognized that, yes, this data is coming from somewhere, and it's coming from maths. And it's, in fact, recognizes that the data has name, address, age, and married status. It has all of that. But then, why is it then throwing a whole lot of compiler error? Let me add this at the back, so it reduces the compiler error. Why is it then having all of this compiler error? This is because the fact that you make or you made a particular struct public, as long as that struct is not inside the particular place you are using it, the particular scope you are using it, that means that the fields in the struct are also private. So each of these fields in the struct needs to add this keyword pub in front of it. Notice that I've added pub here, and that means this name does not have any compiler error again. So that means that for each of them, I need to add pub to each of them. And so adding pop to each of them basically allows us to do what? Have access to all the fields. One might now ask, is it possible to have a situation whereby just a few number of the struct field would have pop and others, for example, would not have? Well, the answer to that is no. For every field element inside the struct, everything must be made public as long as you want to use that struct inside a different file. Every single one of it must be made public. And that's just as simple as it is. So this one must be made public for you to use the struct. So it basically works the same way as the function. Or everything becomes a private struct if the pub keyword is not added. I hope everyone is still together and there are no questions as at now. If there are any questions, you can ask them as we proceed. Remember, asking questions is the best way of learning, as it has proven to, help whatever part you are not getting to understand. So always feel free to ask questions. I can go back, in fact, to the beginning again. If you need me to answer any question, I can go back to the beginning to explain so that everyone have understanding of what we are learning here. So in absence of questions, I'll go back to our slide. So importing slides module with use. Now, introduction to workspaces. Introduction to workspaces. What exactly is a workspace? A workspace allows you to manage multiple related projects. And these projects are seen as crates. So everything within a single repository. What does this mean? This means that you can have, now, there are different frameworks actually you can use for both the front end, if you're writing JavaScript or TypeScript, you basically have React for your front end or something. Now, there are other frameworks you can use, although it's not completely developed in the Rust ecosystem. But you can use these frameworks to write the front end, and then other framework you can use like to write the back end. So all of these frameworks, you can want to, have both your front end, your back end, everything inside the same workspace. What does this mean? This means that you might possibly have up to, if you have 5 or more projects that are related together, you can have all of these projects inside the same workspace. And having this makes it possible for each of these projects to interact with each other. Now, the example you can see on the screen says a particular workspace managing a core library, a CLI tool, and a web API. So you can have all of these things together inside the same workspace, and having it set up, organized in your workspace will allow your code to access each other. And so that means that you can use functions from a different repository, a different project completely in another project. And this allows you to manage and test your complex project. So it's quite ideal for complex projects where you need libraries, binaries, and tests to be managed together. And in fact, the interesting thing is, if you think of Stella, if you go and check the implementation for the example contract, yes, we are definitely going to go there, that Stella uses, it did it in a workspace manner. So if you check the code base is organized where you have multiple smart contracts, and these multiple smart contracts are together inside the same workspace. So as you can see, this is what the structure of the workspace looks like. So basically, the first thing you do is you have the folder. How to set up a workspace? You start by creating the folder, and inside that empty folder, you name it cargo.toml. Inside the root of that empty folder, you create the cargo.toml file, and inside that cargo.toml file, you have something like this inside it. You have workspace, then you add members, and then you now begin to add all the members you want to have inside the workspace. And just like that, if you click on cargo new dash library, call library, whatever you are trying to create, every single one of it immediately is added to the workspace. It becomes a member of the workspace. What do I mean by this? It's nice when we practicalize what we are explaining. So going back to this, we are going to create, for this case, I would click on Stellar Classes, and we are going to create an empty folder. We're going to create an empty folder, and let me close this, and this. So inside this empty folder, we are going to make a directory, and we're going to name it my workspace. Obviously, you don't necessarily have to, use this method I'm using. I just, like using it sometimes. Seed into it, and then you open it. Okay, so for this, I'm going to basically take this here. And now we have this, my workspace. I'm going to increase the size so everyone can see it. So for this, the first instruction is to create cargo.toml file. So inside this cargo.toml file, can you see what you are meant to create? You create a workspace. A workspace, then you add the members like this. So let's go back and do that. A workspace and the members. So you do this, name it workspace. And then members. Did I make any mistake? Okay, I made a little mistake. So I'm so used to adding this. And then members. And then these members, you have this. And inside it, it's empty. So this is basically what a workspace looks like. When you want to start a new workspace, this is basically what it looks like. Now in this workspace, we want to have I would have a file project for front end. I'll name it front end. I'll then name another file back end, and then another one I would name it blockchain. So let's do that. So I'll open the terminal and I'll get the terminal up, and for that I'll do cargo new. I'll name it front end. Now notice that I added front end in the terminal. What it does is it automatically adds the front end to the workspace. Now the front end itself is now a folder that contains the main.rs. In our case, I wanted it to be a main.rs. You could make it a creator, more like a library, whereby you use lib. As you can see from here, you can basically cargo new --lib, and --lib basically makes it a library, a lib, whereby it doesn't have a main function, and the lib is where all other modules are being accessed from. For me, I just want to have my main.rs inside my project. Now, for example, for the front end, we've added the crate for the front end. Now, for this, I would add another crate, and I will name it backend. Notice that the backend has been added to it. The backend is is another folder with its own structure. But then this workspace has included the backend in it. So now the backend can have access to the front end, and each of them have their own cargo.toml, basically. Now, as I made mention, I was going to add blockchain soon. Cargo new, and I'll add blockchain. And now I've added blockchain. So now the blockchain also have its own module. And if you come back to this cargo.toml, it is here. So everything I do inside this main.rs for the backend, everything is done. I can have access to it. If I include the part in the dependency, I can basically have access to everything from the backend in blockchain and in front end. I can basically have access to all of these simultaneously in each of them or in any of them. So I can basically have that. But in this case, I'm not going to work on anything inside any of these things. It's just more like showing you how a workspace is being done and how you can have so many projects inside of the same workspace. So imagine you want to have more like 5 smart contracts, and each of the smart contracts, probably one is for a token, more like an ERC20 token. Another one is for like an NFT token. Another one is more like a smart contract for a marketplace. You can have all of these together in the same workspace, and having the ability to, use, imagine you have inside your marketplace a function, a module that have a set of functions that you call helper functions, and these helper functions can basically be accessed by all of the different, projects that you are working with. So using the workspace basically helps simplify your work, and it basically allows you to, have different projects managed simultaneously in the same repository. If you go back to the example we've been having, you will notice that the target file is here. But then for all of these projects we've created together inside this workspace, notice that the target file is not in any of them. Rather, the target file is below. Below means the target file encompasses all of the compiled binaries of all of the different projects inside this workspace. At this point, does anyone have any question? Can I see a thumbs up to show that everyone is still following up and is still with me? A thumbs up. Okay, great. Okay, great. So, moving on. Managing dependencies in Workspace. Dependencies can be defined for each crate or shared globally. This means that you can have a dependency inside one crate, and then you can also have a dependency that is shared globally. So imagine you install a crate inside of this backend. Remember, the crates will be added as a dependency inside the particular cargo.toml for this backend. You can want it for only the backend to make use of that dependency, or rather, you can have the dependency for different workspace, for all of the different projects in the workspace. So that's basically what that is trying to say. So intercrate dependency. So now, as I've made mention of, all of the different crates can interact with each other. And I said that they can only interact with each other if and only if you define it inside the cargo.toml. So I'll make an example for that, coming back to this. So we want to have, this is the cargo.toml for backend, but we want to have, where is it? Okay, we want to have all of the things inside the blockchain inside the backend. For that, we'll name this blockchain. We name it blockchain. We say it's equal to this, and then we add parts. And then for the parts, blockchain. So doing this, everything inside this blockchain can now basically be accessed inside the backend. What do I mean? So I'm going to make an example of this. Just going to create a function. I'll make it public so it can be accessed. Can see. I'll name the function can see, and then I would call the function and print it out, and then it says I can see you. Okay. This function, I can see you, it's inside the blockchain, but can I see it inside the backend? I want to call it inside here, and I'll just shout can see. Can see. Can I see it? Will there be a problem? Yes, there would be a problem. This is because can see is not inside this scope. But then, does that mean that we cannot really see can see? In this case, we say use blockchain. Okay, let's make it Bob mod blockchain. Blockchain. And then this was it. Can't find blockchain or mod. Okay, we haven't imported it. No, I don't want this. I don't want this. Delete. I don't want this. I'll have this new, and I'll call it mod.rs and work mod blockchain. So in the backend, we have assigned it. Can it not see blockchain? It should be able to see blockchain. This file is not included in any crate. Okay, why is it not included in any crates? We have imported it. Okay, backend. Use, if there is maximum, use crate. Okay, let's use this. Use crate. Okay, blockchain. Yeah. So blockchain is defined multiple times. Let's remove this and use it here. So let's comment this out and see why exactly are we not having access to it here. Unresolved imports in roots. Okay. Unresolved imports. Use, and then is this it? Cannot find. Why can it not find blockchain in it? Why can it not find? It's literally in the crate down. Let's see if this is why. No, this is not why. It might be able to find blockchain in it. Did you spell it well? Blockchain. Okay. Was it meant to have just one? Oh, okay. What was our analyzer saying? Costs. Okay. Cargo watcher field. Okay. Caused by load manifest. This is blockchain. Okay. Reference caused by failed to load manifest for dependency blockchain. Why did it fail to load it? Let's see. Let's remove this. So why did it fail to load it? pub. Okay, let's make this public mode blockchain. Can't see. Why can it not find it? Why can it not find it? Okay. Pub use. Is there a reason why it cannot find? Okay, it has found it now. So here it is. Can see. So this can basically now have access to this inside the blockchain. So backend can now have access to blockchain from here. And that's basically it. To blockchain from here. And that's basically it. So does anyone have any question? It seems our time is fast spent. Yeah, Coxie?
So I'm just going to go back to the code again where I saw pub blockchain and pub use blockchain.
Yeah.
There was a place you imported pub blockchain and pub use blockchain.
Yeah.
Yeah. Can you explain the difference between those two again?
Okay. First of all, I'm bringing in the blockchain here. And then next,
Okay.
I'm using it here. Pub use means I'm making it public and using it inside this main.rs.
So does that mean now that if you want to use it, you must first of all bring it in, then use it? Can't you just put pub use blockchain just like that? So
And you can do that. You can do that. Definitely, you can do that also. You can do that. If I remove this, there's no problem. You can do that, but I just chose to add that here. You can do that. There's no compiler error coming in. You can do that.
So you mean that you imported all the module from the blockchain into the backend?
Hello.
Hello, can everyone hear me? Hello, can everyone hear
Yes,
me?
I can hear you now.
Okay, sorry, I think I had a little hiccup here. And for that reason, I could not hear anyone. So I'm listening to you, please. Coxie, you're asking a question, I'm listening.
Sorry, I don't know. I just had to comment that it does that mean now that you use the blockchain was another it's called module or called package somewhere else. So it means that you imported all the module inside the blockchain into the back end, right? That's what you did. I don't know if I'm using the right
Yes,
words.
I imported it in. Yes, I imported it in. I imported it
Okay.
in, basically.
And for you to import it, you had to go to the cargo.system some file.
Thumbnail file, and then add the path.
Thumbnail file.
Yes, add the path there. I basically added the path there for me to have access to it. So yeah.
All right, thank you.
Yeah. So we are not done with our slide, but our time is fast spent. So we are going to continue from where we stopped on Monday. I understand that Workspace can be a very large topic when it comes to explaining it in Rust. And yeah, I thought we would have enough time to cover it today, but unfortunately, we could not cover it. But on Monday, what I have made mention of about the quiz, we will possibly not have the quiz on Monday and just complete this lecture slides today. And then on Monday, we can definitely have the continuation. And on Tuesday, we definitely have the quiz. But if there's enough time for us, based on if there are more questions on what the lecture looks like, we might definitely have the quiz. But until then, see you everyone on Monday. I would be stopping the recording now. So thank you very much and enjoy the rest of your day.